So section 10.5, we're going to work with segment lengths in circles. So we worked a little bit with segment lengths in circles back in section 10.1. If we had two tangent segments that met at a common point, then they were congruent. So remember, a tangent segment is going to go from a single point on the circle to a point not on the circle. A secant segment is going to go through the circle twice and go to a point outside. And a secant segment has two parts. It has the internal portion, which is the chord inside the circle, and the external portion, which is outside of the circle. So we're going to work with three theorems. One of them deals with the lengths of two chords. The other one deals with the lengths of two secant segments. And then the last one deals with the length of a secant segment and a tangent segment. So first we're going to work with theorem 10.15. So with this one, we're dealing with two chords that intersect. And we're going to have the product of the lengths of the segments of one is going to be equal to the product of the lengths of the segments of the other. In other words, we're going to take and multiply the two pieces of a chord together. So we take our first chord, and we're going to multiply the pieces together, so 5 times x. And then we're going to take the second chord, we're going to work with the second chord, and we're going to take the two pieces of this chord and multiply them together. And these two products are equal. So 5x is equal to 16. When we divide, 5 goes into 16 3.2 times. So for each one, we're going to take our chords and multiply the two pieces together. So we take our first chord, we're going to multiply the 2 times the 3x. And we're going to go to the second chord, and we're going to multiply the 3 times the 8. And we're going to set them equal to each other. So this is 6x equals 24. When we divide by 6, x is equal to 4. Once again, two chords. We take the two pieces of our first chord and multiply them together. We take the two pieces of our second chord and multiply them together. And these two products are equal. X times x, remember, is x squared. 4 times 9 is 36. To remove the square, we have to take the square root. And since we're dealing in measurement, we only need the positive square root of 36, which is 6. So two chords, we multiply the segment pieces and set them equal. So in the next one, we're working with two secant segments. So with two secant segments, they have to have the same endpoint. So we'll notice in each of these we have a common exterior endpoint. We're going to be doing the product of the length of the secant segment and the length of its internal, and this will equal the product of our other segment and its external segment. So for each one, we're going to do a multiplication. So we're going to take the length of the entire secant. So remember to add the pieces, 4 plus x. And we have to put this in parentheses. And we multiply it by its external portion. We do the same thing with the other secant segment. We need the entire thing. So 5 plus 4 is 9. And we're going to multiply it by its external section, which is 5. And we set these products equal. So we have to distribute. So this is 16 plus 4x equals 45. 4x is going to equal 45 minus 16, which is 29. And then we're going to divide by 4. 4 doesn't go evenly into 29, goes into it 7 times. And when we round, this one is going to round. So 29 divided by 4. Well, fine. 29 divided by 4 is 7.25, which is going to round to 7.3. So each time we need the entire segment. So 6 plus 3 is 9. We multiply it by the external portion. So each time we're going to take the entire x plus x, remember, is 2x when we combine our like terms, and we multiply it by the external, and our products are equal. So this is going to be 27 equals 2x times x is x squared. So we're going to divide by 2. So 27 divided by 2 is 13.5. And then to remove the square, we're going to take the square root. So we're going to do the square root. My calculator up. Let's enter the square root of my previous answer. And we get, rounded to the nearest tenth, 3.7. So in our next one, we start out with the entire secant. So we add the 2 pieces. Remember to put the addition in parentheses when you can't combine it. And we multiply it by the external portion. We do the same thing with the other one. We need the entire piece, which is 5. And we're going to multiply it by the external section, which is 1. These products will be equal. So when we distribute, this is 2x plus 1. Multiply, we get 5. We subtract the 1, 2x is equal to 4. We divide by 2, and x is equal to 2. If we have 2 secants, it's always the external times the whole thing for each of them. So it's our external times the whole thing, and then we set them equal. So you're always taking the external and multiplying it by the whole segment. There we go. So our last theorem This time we're working with a secant and a tangent, and they have an endpoint outside the circle. So we have a secant and a tangent. We have their exponents outside the circle. So for the secant segment, we do the same thing we did in the previous, the product of the length of the secant segment and the length of its external portion. And this will equal our tangent portion, where we have to square the length of the tangent. So our calculation with the secant portion is the same as the previous one. So our secant, we need the whole thing in the external portion. So it's always the whole times the external. And then for the tangent, which is just the single piece, we take this one item and we square it. We take whatever that measurement is and square it. We set these equal. So 11 times 5 is 55 equals x squared. To remove the square, we're going to have to take the square root. So I'm taking the square root of 55. Rounding to the nearest tenth will be 7.5 for the value of x. So once again, our secant, we add the two pieces to get the whole thing, and we use the external. So it's the whole times the external. For the tangent, where there's only one piece, we square it, and we set these two calculations equal. So 16 times 12 is 192. And then to remove the square, we're going to take the square root. So we need to do the square root of that answer. And it is rounded to the nearest tenth, 13.9. One more time. We're working with this one. Our secant is the same calculation as before. We have to get the whole thing. We usually have to add the pieces. 4 plus 9 is 13 to get the whole thing. And we use the external portion. So it's the whole secant times the external portion. And then for our tangent, we take this tangent measurement and we have to square it. Now be careful, if it's more than just a single variable, make sure you put it in parentheses. So it's a multiplication problem that's squared. Put it in parentheses. We're going to set these equal. So 13 times 9 is 117. When you have to square 2x, you have to square the 2 to get 4, and you have to square the x to get x squared. We're going to divide by 4, so we're going to take that previous answer of 117 and divide it by 4 to get 29.25. I don't want to round yet. And to remove the square, I'm going to take the square root. So I'm going to do the square root of my previous answer and round it to the nearest tenth. It's 5.4 for the value of x. So keep in mind, anytime you have a secant, it's always the whole secant times the external portion, and we take our tangent section and square it. So for the secant, it's the whole times the external equals the tangent squared. If you have two secants, you do the external times the whole thing for both of them and set it equal. So the external times the whole equals the external times the whole for each one. So this is the first one and the second one. And when you have chords, you simply take the product of the two pieces of each chord and set them equal. So multiply and set equal for the chords, the external times the whole and set equal for two secants. And if you have a secant, it's always the whole times the external, and for a tangent where there's only one piece, we square it.